the parity. If the parity disk crashes, I have the original data. That's one approach. And these are the levels of RAID structure. By level, I mean the versions of the RAID structures. And these are the different structures again. I guess the most popular one is this one, or maybe this one. I guess this one is the most popular one. These are the RAID levels. Okay, let's talk about a little bit about the disk formatting. Okay, after manufacturing, there is no information whatsoever on the disk, so we need to do some kind of a low-level format. Okay, when you do the low-level format, you need to structure your sectors. Okay, you remember those sectors inside the tracks? Each sector has this kind of information. Remember, sector has, okay, sectors per disk, this much, bytes per sector, 512 bytes. So I have 512 bytes here. But before the sector data, there is a preamble and there is an ECC. This preamble data includes a bit pattern that says that the hard disk controller that the sector is beginning. Okay, so it's a special pattern. It says that there is a sector is beginning, so the disk head knows where it is. It also contains the cylinder and sector numbers, so that it would be sure that it is reading the correct sector. ECC field contains redundant information that can be used to recover from read errors. You read it, okay, you read your data, you read your ECC, and the data doesn't match. That means that there is something wrong. Maybe this is a bad sector, it doesn't work, there is a problem with the sector. So the sector might be marked as a bad sector. Okay, so this is called low-level formatting. Low-level format means that, okay, you are writing your sector information to all the tracks, to all the cylinders of your hard drive. That's why low-level formatting takes lots of time. It takes lots of time because you need to reach every corner of your hard drive, and you need to create all of your sectors. In this case, you need to write this many 500, almost 600 million, 600,000 million or thousand, I don't know. What is that number? 1,000, right? Almost 600,000 sectors need to be initialized with the low-level format. When you initialize that, actually you are checking if the sector is good or bad. If it is bad, then you are marking it as a bad sector. Let's look at the structure, and after this we are gonna stop and continue tomorrow. So these are the sector numbers. Okay, let's look at this one. Or maybe where is 0 for the, okay, let's look at this one. The disk spins this way. 0 is here, sector number 0 is here, but see, this is called cylinder skew. So question is, why do you think they organize the sectors numbers this way?
Bir defa sıfırların içinde koyuluyor sürekli. Aynı sayılara koyuluyor. Birinden diğerine gidene kadar.
Yeah. When you are reading this track, yeah, that's the correct thing. Okay. When you are reading this track, okay, your head is stationary, your disk is spinning. Okay, your disk is spinning. So when you read this track, you want to read the data, continuation of the data from this track. So you need to move your disk head from this position to that position. But moving the disk head from one position to that position takes how many times? 0.7 milliseconds, right? That's a lot of time. When you move your disk from one position to that position, it's going to take time. During this time, this continues spinning. So when you move from this position to that position, the disc is going to spin and this part will come to that place. That's why it is structured in a skewed way, so that when you move your head, the cylinder moves and it comes under your head and it is ready to be read again. So this is structured in a way that you can continuously read tracks one after other on the adjacent tracks. Otherwise, if I make this 0, these are all 0. If I move from this position to that position, I need to wait another disc spin, disc rotation, so that I can catch up with the sector number 0. So discs are structured that way so that I can continuously read tracks one after the other without waiting for the tracks to spin. Okay? So this is called cylinder skew. Okay, I guess I'm going to stop here and we will continue tomorrow.